Okay guys, so today we're going to talk about section 5.4, and it's basically just solving right triangles. Has a lot to do with what we did yesterday. We're just going to use the trig functions to find the missing sides of right triangles. Again, what we're doing right now only works with right triangles, and it won't be until later that we learn how to deal with other kinds of triangles. So let's look at example 1 in your book. In this example, you've got a right triangle. Let me draw that better. Okay, so we've got the angle, which is 35 degrees, and we're told that the hypotenuse is 14 degrees. We know that's the hypotenuse because it's opposite the right angle. Um, since this was the angle that we're given, this leg here is the adjacent angle, and this is the opposite leg. So the information that we know about this triangle is we know theta is 35 degrees. We know that the hypotenuse is equal to 14, and we're trying to find the opposite, and we're trying to find the adjacent. We can find the opposite by using sine and realizing that the sine of theta is equal to the opposite over the hypotenuse. And so the sine of 35 degrees is equal to the opposite over 14. If I multiply both sides by 14, I'll get 14 sine 35 degrees is equal to the opposite. You can use a calculator to solve for that. You want to make sure that your calculator is in degrees and not radians, so you want to come down here to angle, switch to degrees, and then you'll be fine. So I'm going to type that in, 14 sine 35, and I will get 8.03. I can also find the other side by doing the exact same thing, but I'll use cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. So the cosine of 35 is equal to a over 14, or 14 cosine 35 is equal to the adjacent. I can type that into my calculator. And I'll get 11.47. Okay, let's try another example. Just give me 2 seconds here. Okay, let's look at example 2 in your book. Here we've got, again, another right triangle. We're told that this side is 40. Here's the hypotenuse, which they call r, and then this is the variable d, and the angle that we're given is 52 degrees and 15 minutes. So we're going to need to convert that to a decimal. Theta is equal to 52 degrees plus 15 divided by 60. So that's 52.25 degrees. And we also have the opposite side, which is 40. We're looking for r. which is the hypotenuse, and we're looking for d, which is the adjacent. We can find the hypotenuse by using sine. So the sine of theta is equal to the opposite over the hypotenuse. So the sine of 52.25 is equal to 40 over the hypotenuse. If I solve that for the hypotenuse, I'll get the hypotenuse is equal to 40 divided by the sine of 52.25. And I can plug that into the calculator really quickly. It's 40 divided by the sine of 52.25, and that'll give me 50.6. Okay. I can also find d, or the adjacent side, by using tangent. The tangent of theta is equal to the opposite over the adjacent. So the tangent of 52.25 is equal to 40 over d, and then d is equal to 40 divided by the tangent of 52.25. I can type that into the calculator. And that'll give me about 31. Okay, that's pretty much all you're doing today. Just using the sine, cosine, and tangent to find missing sides of right triangles. Your homework is on page 302, and it's 10 through 20 all. If you have any questions, I'll be here after school in the lower school science lab.